you want to make sure that you know how to do all this stuff by hand. But let's start with the calculator problem. This is on the spring break problem day sheet that we looked at before, and it's problem number 1. Gauss-Jordan reduction. This is a big scary term, but it means put all the numbers into the matrix. Put the matrix into your calculator. And we know how to do that, right? Second matrix, edit. How big is the matrix I'm going to be putting in here? What are the dimensions of this? 3 by 4, always rows by columns. So tell it 3 by 4 and then put in the numbers. And then who remembers what we do once we get all the numbers in on the calculator? Alexis? You second quit. It's one of those weird things about the matrix menu. You have to keep going out and in all the time. All right, so the matrix is in, second quit. Now, I'm ready to do something to it, right? You remember what button? Ethan?
It's the RREF.
RREF, yep. Reduced row echelon form. That's what that stands for. That's not a test question, don't worry, but that's what it stands for. So, to get that, we go back into second matrix, over to math, not to edit, we already edited, we already put the matrix in, go over to math, and then all the way down to get to RREF, enter, and then second matrix, enter again. And did you get this matrix? Did you get 0.68 and 1.8 and 2.72? Now, with those particular numbers terminating decimals, there's nothing wrong with that. But sometimes when you do this, you get those big long, going on and on forever decimals. So remember, we press math, frac, and if you preferred, you could answer in fraction form. Now, again, listen to me. If the decimals are big, long ones that go on and on and on and on, no rounding off. Change them into fractions. But if they're nice terminating decimals like this, it's okay either way. And then you will write your answer as the ordered triple that it is, either using the decimals or the fractions. Because what you now know is, if I let x be this, y be this, and z be this, all these equations will work out. Sir?
So then on like the test when we show our work, do you need to see like
This, the matrix that goes in, and the matrix that comes out.
on the paper?
On the paper.
Okay.
And to help you out, I've actually drawn the matrix, put the arrow, and drawn the matrix.
Okay.
So that you won't forget. Yep. That's the only work you have to show. All right. I think we did number 2 the other day. We'll do some more practice, don't worry. Did we do 3? All right, let's do 3 because that's also, all these are test questions. These are all going to be on your test. So now we're going to do number 3, and it is not a calculator question. You are going to have to do this one totally on your own. We're going to label all asymptotes, poles, and intercepts. So we need to find x-intercept, y-intercept, poles, vertical asymptote, and horizontal asymptote. This is actually an easier problem than some because you don't have to factor it. It's ready to go. If the problem factors, you want to factor it. Nothing factors here, and because of that, there won't be any holes, because in order to get a hole, you have to be able to cancel, and you can't cancel until you can factor. So we're done, no holes. What can you tell me about the rest of it, though? Can anybody give me any of that, sir?
Your x-intercept is 2.
Yep, 2 comma 0, that is indeed. That is the number that when I plug it in, it gives me a 0. It's called a 0, an x-intercept, a 0. Comes from a numerator, always.
Your horizontal asymptote is
1/2. Y equals 1/2 is my horizontal asymptote. Very good, because when I look at my problem, I have x over 2x. That's 1 over 2, 1/2. Perfect. All right, what else? Ethan?
Isn't your y-intercept -2?
It is, because if I put in 0 for the x's, I get -2 for my y. We have office hours tomorrow and Friday, so if any of this is like foreign language to you, get your little Annie in here. All right, Ollie?
Isn't the vertical asymptote -2?
Be careful.
Or did that?
-1/2. The vertical asymptote is x equals -1/2 because that's what makes the denominator 0. So Ollie, if you have, if it's weird like that, you can't do it in your head, actually set it equal to 0 and solve it, and you'll get -1/2. That's your or your vertical asymptote. Now that is everything I'm supposed to have in my picture. So based on that, hopefully you can draw a picture. Remember, we approach our asymptotes. So we're going to get closer as we head out and closer as we head down, right? And what else? That's only half the picture. What else, sir?
In the second quadrant, that little thing,
Yep, exactly. Exactly. All right, everybody okay with that? Test question. It's already been a test question. It's a test question again. Number 4, evaluate with no calculator. Do you remember how to do this?
Yes.
This is called a determinant. And you are going to evaluate it. All right, someone new. Someone new, raise your hand. Abby?
You write the first 2 to the right and then do the diagonal.
1, 2, 3, 4, 2, 1. So I recopy the first 2 columns. And then she says, then you multiply the diagonal. And because I've graded so many zillions of papers, I know where the mistakes come. When you evaluate a determinant, you start here. This multiplication is first. That's the beginning. So I get 4 and 0 and -3. So I got 1 when I totaled all those up. 4 and 0 and -3. Total them up, I got 1. Now, go the other way. So that's -8 and 0 and 6. So that one is -2. Now what do I do with these 2 numbers? My answer is going to be a single number, so I have to do something for these 2. What do I do? Subtract. So 1 minus -2. So the value of this determinant is 3. Sir?
So every time it says evaluate and it just gives you the matrix, Is that always mean determinant?
Well, what means determinant are the vertical bars. That is not matrix notation.
Okay.
That is determinant
So
notation.
then would it ever be evaluate with the matrix
Nope.
determination?
Nope,
Okay.
I mean, you can multiply, but it takes two.
Right.
There's nothing to evaluate in a single matrix.
Okay.
All right. Number 5. Okay, I really want you to practice this one on your own for a minute. Maybe lean over and help your partner. But we are multiplying matrix B times matrix A.
No issue.
Remember, sometimes you can't do this. This time you can, because the dimensions of matrix A are 2 by 2, and the dimensions of matrix B are 2 by 3. And the rule for multiplication is the inside ones need to match. Okay, is any of this sounding familiar, I hope?
Yes.
Okay. This is number 5. Did I copy it wrong? Well, it says multiply B times A. Find BA. So here's B.
Commutative matters.
Oh, yeah.
Just like you can't do A times B, you should do B times A.
Exactly.
Oh.
Yeah. I can't do A times B. As Sir said, does everybody get A times B isn't gonna work. So I'm doing B times A. Okay. Now, I'm doing B times A because that's what the problem says.
So then,
I don't just randomly change. I do it what the problem says. Okay. Now, my answer is going to be another 2 by 3, right?
Yes.
So it's gonna have 2 rows and 3 columns. So this is what my answer is going to look like. Now I want you to see if you and your partner can remember how to fill in these blanks. Because this is a problem that's missed a lot too. How do we fill in these blanks? Think about that for a second. You and your partner figure it out and then we'll check our answers.
and then two times yeah.
Oh, this is my favorite one. I'm gonna check my answers. They're on the back. This is what, 5? Oh, no, I took it wrong.
All right, I'm getting ready to check here, since I finished putting in my attendance. All right. Who got it done? Anybody have it done? All right, Joanne, who hasn't even been here for forever, what is the top row? 4, negative 1, 10, and your bottom row? All right, let's take a look at that. I did not do those. Does anybody have an argument with one of them? Do we need to look that over? That looks good to everybody? Good work. Nobody has a question about where any of those numbers came from? Perfect. Perfect. All right, number 6 says solve. How shall we solve this guy? Notice there are no directions. It doesn't say solve using, it just says solve. You could not do Kramer's rule on this problem. That's one of our options now. You can't do it because of the squared, but you could substitute or eliminate either one.
It might be easier to subtract the negative 2y over, and then do negative 2y plus 1 squared.
Okay, so what Sir is suggesting, he wants to do substitution. So he says, I'm going to get this x by itself. Okay, take that equation and subtract the 2y. Is that okay with you? And then he's going to take this right here and substitute it in right here. So he's going to have 1 minus 2y quantity squared plus y equal to 2. Now, this isn't the only way to do the problem, but I think he's okay. I mean, I think he's on to something here. All right, what's next then? Do not screw this up. What's next? Foil, foil, foil. So 1 minus 2y times 1 minus 2y. I'm foiling. So 1 minus 4y plus 4y squared. Don't let me pull a fast one. I collected like terms. Now what? This is kind of not good. What now? What kind of equation is that?
Quadratic.
So I need to get it set equal to 0. So 4y squared minus 3y minus 1 equals 0. All right, double check me. 4y squared minus 3y minus 1, because I have to subtract the 2. I heard somebody say quadratic formula. Actually, I think that does factor. At least it looks like it does. But, do you ever have to factor? No. If you want to do the quadratic formula, that is A-okay. But I think this one does factor. Regardless of whether you do the quadratic formula or you factor it, you're going to get y values of negative 1/4 and 1. And I like to write them that way because it reminds me that I still have work to do. I still need to find the x's. Doing it the way that Sir did it, remember, x is 1 minus 2y. So can't I find my x values by just plugging in my y values right here? So let's see, this is going to be 1 plus 1/2, so 3/2. And 1 minus 2, negative 1. There are the answers to the system. Some of you missed that in a homework. I mean, it's a different problem, obviously, but you might want to take a look at that homework. make sure you got it. I think, I meant to, I hope I remembered. I think I uploaded or downloaded or whatever, the answers, the homework answers in Schoology. So if you wanna check, yep, they're all there. So if you wanna do, check your homework in Schoology, you know, I've returned it, marked it wrong or whatever, or you submitted it electronically, feel free to do that. All right, everybody up to speed here, we ready to move on? All right, now we've got one on the back, but I didn't print the back. So, you'll have to wait on that one. And then we're gonna do B inverse. I don't think we did that one. So B in problem 5 is the matrix 2, 1, negative 1, 5. And we're gonna find the inverse. Who remembers how to do this? Alexis?
Don't you have to solve the, like,
You know what you mean. I have to find the determinant.
Yes.
Yeah. And so the determinant of this thing is gonna be 10 minus negative 1. Did you get 11? For the determinant? Now I'm gonna hang on to that number. And now I have to build a, Gracie Foo, you paying attention?
Yep.
All right, I need to build a new matrix. Lillian,
You switch the 2 and 5 and switch the signs for -1
exactly,
and
so
1,
5 here and 2 here,
and then switch the negative.
positive 1 and negative 1. Now, with these numbers, it kind of looks like I switched these, I didn't. I left that one right there, but made him positive, left that one right there, but made him negative. And then Caroline, last thing I need to do is
And then put them all over 11.
put them all over 11. And that's my inverse. So what I put in the answer blank is 5/11ths, negative 1/11, 1/11, and 2/11. Usually, there's some kind of simplification that happens here, whether it's negatives or canceling or whatever. This time we didn't really have any. It just came out to what it was. And I circled number 9, I think we did it already. So that takes care of that sheet, except for the problem I didn't run off. So now what I would like for you to do is to find the sheet called, or it's page 7, find page 7. You may cross off, you're not responsible for Gaussian elimination. We have only done Gauss-Jordan reduction. That's when we do the RREF button. So you can change those directions to Gauss-Jordan reduction. That's all you're gonna be responsible for doing. If you look at the answers, it's gonna be a little weird but we're not doing that. We've already practiced that one, and 1 and 2 are the same. So if it's okay with you, let's spend a little time with number 3, making sure that we have all of our matrix operations taken care of. Is there anything at first glance, anything at all in number 3, A through K, that you look at it and you think, oh, I don't think I remember how to do that? Which one?
Oh, no, I knew how to do this. I was just like, oh, no, I don't think one of these can work.
You know how to do them all, okay. Is there anything that bothers anybody? Ethan?
The J.
J? Because either I didn't talk about it or I use different notation perhaps. When you put the little subscript, or superscript T, that can be a capital T or it can be a lowercase t. It doesn't matter. when that T is written above, did we talk about that?
The transfers.
That's the transpose. It's the transpose. Does anybody remember what it means to transpose? You asked the question.
Well, is that the one when you switch the columns
Yep.
and the rows?
Yep, you transpose the rows and columns. So, matrix C, the first row is negative 1, 2, 1, so that becomes the first column, and the second row becomes the second column. So this is C transpose. That's the transpose of C. Every matrix can be transposed. If the original one, C, is 2 by 3, then clearly the transpose is going to be 3 by 2. You switch the rows and columns, so the dimensions flip-flop. Okay? All right, anything else? Donovan? A? A says add A plus 2B. Now, sometimes that's not possible. Is it going to be possible for me to add matrix A and 2 times matrix B? Is this going to be possible this time?
Yes.
Yes, because the rule for addition is they have to be the same size. They do not have to be square, but they have to be the same size. So, Donovan, I'm going to add this matrix to this matrix. Remember, when you multiply by a number, what's this number called? Scalar. Scalar, it's called a scalar. When you multiply a matrix by a scalar, you just like distribute it. And then when we add Donovan, it's position, the corresponding position. So I'm just gonna add these two together and get negative 1. I'm gonna add these two together and get 9, 14, and 17. And that's the answer to the question. Some of these problems, though, will have no solution because they're not always doable.
Wouldn't an A plus C not be as something that we can do?
A plus C would not be addable. Also, look at problem C. That's no solution. C can't be done. Problem C cannot be done. Why? Somebody tell me. Why? Ethan?
Square
It's
matrix.
not square. You can't do a determinant, hence you can't do an inverse if it's not square. So C would be no answer.
E would be no solution too.
Which one?
E.
E, yeah, you can't find the determinant of C. It is not square. Can you do H? Can you multiply C times D?
Yes.
C is 2 by 3. D is 3 by 3.
It'll be a 2 by 3 answer.
So your answer will be a 2 by 3. That's possible. What about I? Can you multiply C, which is 2 by 3, times B,
No.
which is 2 by 2? No. So I is a no solution problem. Can you do K? Can you subtract B minus A?
Yes.
Yep, they're the same size. Abby?
For I, you just cannot do with that being covered long.
No, cannot do is fine.
Oh.
Empty set is fine. Impossible is fine. Anything else in problem 3 that we need to look at? So we think we got the rest of it under control?
And subtracting the size addition.
Yep. Okay, then 4 and 5. These are test questions. You will have to demonstrate your ability to use the inverse method and your ability to use Kramer's rule. So let's refresh our memories. This is number 4. I am doing the inverse method. All right, does anybody remember what happens here? Sir?
So you like put like one, like the matrix will like 1, 2, 5, 1.
Okay, so I'll call it A, and it's 1, 2, 5, 1.
And then
Just a second. In other words, I'm making a matrix out of the coefficients. Everybody see that? Okay, then
isn't it like matrix B would be 4 and 2?
B is gonna be 4 and 2. The inverse method requires me to multiply A inverse times B. That's how I'm going to get my answer. If I'm doing this by hand, which you are, no calculator, you're gonna need to find A inverse. Well, you already know how to do that. We've already practiced it. To find the inverse, first we'll find the determinant. What's our determinant?
-6.
What is it?
It's 1 minus 10.
-9. Then we build that new matrix that we were talking about earlier. So we're gonna switch the 1 and the 1. I'm going to change the signs on these guys. Everybody still following along? Then we'll divide all those numbers by our -9. And that will be my A inverse. So my A inverse is -1/9, 2/9, 5/9, and -1/9. That's A inverse. To use the inverse method, you multiply A inverse times B. We just practiced multiplication. You all said you got it. This is a 2 by 2. This is a 2 by 1. So my answer is going to be another 2 by 1. This is going to be X and this is going to be Y. Because I'm looking for a point just like I was earlier. So row 1, column 1. So -1/9 and 2/9 times 4 and 2 added up. Remember, when you multiply by a whole number, it's like over 1. So this is -4/9. Oh my gosh. And that is also 4/9.
So it cancels 0.
So I got X equal to 0. And then I'll take row 2, so 5/9 and -1/9 times 4 and 2. So this is 20/9 minus 2/9. That's 18/9, which is 2. So the answer to the problem is 0, 2.
And you could do it where you just plug 4 and 2 in, right? I mean, that's what I just did, or did we do the same thing?
What do you mean?
So I got -9,
Mm-hmm.
and then I made a separate thing again. I did 4, 2, and then 2 and 1. I did that.
That's Kramer's rule.
Kramer's? Okay.
Yeah, and we're gonna do that next. So, in the real world, not in math class, it doesn't matter, just solve it. But on your test, there is a question that says solve using the inverse method. So I will be looking for this matrix being timesed by this matrix. That's your inverse method. Okay, are we clear on this? Inverse method. That's what I gotta see. Now, the next problem says solve using Kramer's rule, and that's on your test also. But I'll be looking for different things with Kramer's rule. So I don't know if you heard what he was talking about or not, but with Kramer's rule, I don't do any matrix multiplication. I basically do 3 determinants. I get my answer from 3 determinants. The first determinant I do is the same as the one I did over there. It's of the coefficients. So 1, -3, 2, and 5. So let's see, this one works out to be 11 again? Or I guess that one was 11, that was 9. I get 11. And I am looking for an ordered pair, just like I was with the inverse method, or substitution or elimination. And I know that that ordered pair, the denominators of x and y will be 11. And then the numerators are 2 more determinants that Jeff was talking about. Remember how that works? If you're solving for the x numerator, take the 2 and the 8 and glue them in the x column. So 2, 8. If you're solving for y, glue them in the y column. Everything else stays the same. So if I glue that here, I'm going to have -3, 5. If I glue it here, I'm going to have 1, 2. Do not move anything. You cut and paste. Okay, then evaluate these. So 10 minus -24. I got 34. If I did that right. And 8 minus 4, I got 4. And there's my answer. If I did the inverse method, I get the same answer. There's only one answer. But I'll be looking for that, and that when I grade this problem. Because that's Kramer's rule. All right. Number 6 was on the quiz we took. You need to practice that one. Do you remember? Some of you had trouble building your vectors, and I don't think it's because you don't know what to do. I think it's just because you were a little careless. So if I have, I'll just come in. You don't need to do the whole problem if you don't want to, but I do want you to take care with building the vectors. So I'm going to choose the way I have this thing oriented. I'm going to find BA and BC. So vector BA and vector BC. BA, BC. Now, in going from B to A, how am I moving? 3 to 1. That's -2. 1 to -2. It's -3. Signs matter, negatives matter. Now, B to C, 3 to -2. -5. And 1 to 3, 2. Now it's going to happen on this one. The way some of you set your quiz question up, when you built the determinant from those numbers, the numbers were different. But when you built your determinant and you evaluated it, in this case, we're going to get -4 minus 15. I'm going to get -19. Then I divide by 2. and some of you left the negative. Area can't be negative. Ignore the negative. Because if you set up your vectors in the other order, if you put this one on top, it'd come out positive. The negative doesn't matter. So the area of that is 19 halves, or 9.5. Square whatever. Well, I can't read the last question.
Question about that.
Okay.
If you use different,
Vectors are the answer is the answer.
you're determining what you use different.
Your determinant's gonna be 19, no matter, 19 or negative 19, no matter what. So what vectors did you use? Did you
Oh,
find it?
never mind, yeah.
Yeah, I got the same
3
thing,
times
I used
3
different
is
vectors.
6.
Yeah, so his question was, if I use different vectors, my numbers are gonna be different, and you're right, but the determinant's gonna be the same. Either 19 or negative 19, it's gonna be the same. Izzy?
Oh, I wasn't raising my hand.
Oh.
Sorry.
All right, let's look at that back side, and let's take a look at that word problem. Because there is one of these on your test. Yep, exactly, so just like this. Okay, so Ted is taking his vitamins. So would you read the problem and fill in your chart, please? Read the problem, fill in the chart. Do my numbers look like your numbers?
Since it's 6 and 8 cents, would you put 6.08 because it's cents?
It doesn't make any difference.
Okay.
I'm just gonna know that when I start a value, you know, once I get my vertices and I plug them in, my answer is gonna come out in cents. So if I get 32, it's gonna be 32 cents.
Okay.
And you're gonna get 0.32, which is the same thing, fine, doesn't matter.
Okay.
Doesn't matter one bit.
So, okay. Wait, so what would your answer be? Like if you
Mine's gonna be
did
cents.
Mine would be
Dollars, $0.32.
okay.
Which is the same as 32 cents.
32 cents. Yeah.
How do you know that was like it came down to like the minimum and not like the max?
Okay, because the question says, how many pills should he take in order to satisfy his need most economically? What does that mean? Cheapest. Cheapest means least cost, right? Yep. Yep. So sometimes it doesn't actually use the word minimum, but you gotta kind of interpret that. All right, what are my constraints then? I gotta start writing some equations here, some inequalities. What are my constraints? Okay, I love my favorite two because they talk all the time. Let's get some new action. Abby?
2
a greater than problem, that's the minimum daily need. He needs at least 4 milligrams or whatever it is, right? All right, Ollie,
For the next one, you can do 3x plus 4y is greater than or equal to 11.
perfect. And then what's my last one? Perfect. And I think for this one, I can just use a scale of 1. I think that'll be fine. Actually, I guess I've scaled this for you, a scale of 1/2 to spread it out a little bit. So, all right, so remember how we graph these. Feel free to bring colored pencils or pens or something on Friday. When we graph it, we cover up one letter be 0. So if I let x be 0, y is 4. So 1, 2, 3, 4, you do yours on whatever graph paper you got there. And then if I let y be 0, x is 2. And I connect them with a nice straight line. Use a ruler if you want, a straight edge of some kind if you want. And that is shaded out. Yep, above. So this is where I'm shading now. Okay, everybody okay with that? All right, now I'll do this one in red. So 3x plus 4y is enough. Kids, we're not panicking. We're going to get decimals. It's going to happen. It's okay. If I cover up y, y be 0, x is going to be 11/3, which is about 3.6 or something.
6 repeating.
So I'm going to come out here. There it is, 11/3, comma 0. And then, same thing's gonna happen. I cover up x. Y is gonna be 11/4, which is about 2.75. You have a calculator for this problem. So even if decimals arise, you can handle it. That one is shaded out also.
Yes.
And then finally, these are big numbers, but they're all gonna cancel out. If you cover up x, y is just 2. And if you cover up y, x is 4. And that is also shaded out. So I have all of this shaded here, and the corners of that shading are right here, right here, right here, and right here. Here's my shaded region, the outermost parts. Did everybody agree with that?
Yes.
So the points are 0, 4, and 4, 0. And then these guys, which are intersections. So let's see, this is purple, this point right here where I'm pointing is purple and red. So 2x plus y equals 4, and 3x plus 4y equals 11. My purple and red are intersecting right there. Inverse method, Kramer's rule, substitution, elimination, whatever flips your switch. I think eliminate, you know I'm always gonna eliminate, so I'm gonna multiply that top row by -4. -5x equals -5, so x is 1. And if x X is 1, Y is 2. So there's the point 1, comma 2. Did everybody follow that? It's a lot of work, big problem. Now this one is the intersection of red and blue.
To make your number smaller, could you just divide by 25?
Absolutely, so that's X plus 2Y equals 4. So Sir says, I really don't want to mess around with these numbers, I can do it, but this whole equation is divisible by 25, and if I do, it looks like this. And then it's easier to work with, so, I don't know. 3x plus 4y equals 11. And negative 2x minus 4y equals negative 8. I got x equals 3. And if x is 3, ooh, is y 1/2? Now, fractions aren't necessarily great in a lot of problems, but what do these represent? What do x and y represent?
The
Violence.
brands.
No, x and y aren't the brands.
It's the
X and
vitamins.
y are the number of pills of each brand I take. So this says I'm gonna take 4 type X pills. Well, can I take half a pill? Have any of you ever taken half a pill before? Yeah, I got a crazy wild cat, we have to give her half, right? So, yeah, it's okay to have fractions in this problem. All right, let's find the cost for each one. And we'll do that by plugging it right here. You can use decimals or not use decimals, it's up to you, you've got a calculator. So 18 and 4, I think this one's 22 cents, double check my work if you would.
Yeah, it's 22 cents.
1 and 2 is 22, is that 22 also?
Yes.
4 would be 32. And this one's 24. Oh, I'm not sure that's happened to us before. We're looking for minimum cost,
This too.
and now he's got a choice, right? What are you gonna tell him? Either take 3 X's and a half a Y every day, or take 1 X and 2 Y's. If it's me, I'm going this way because number 1, it's fewer pills to take, and number 2, I don't have to mess with cutting them in half, right? But he really does have a choice. You all right with that? Okay, here's your task for tomorrow. Oh gosh.